Welcome to The Explainer. Have you ever been deep in thought, wrestling with a tough problem, when you just stop and think to yourself, wait, hold on, let me rethink this. What if I told you an AI was having that exact same thought? Today, we're going to peek inside the AI's mind to see how it really, truly thinks.
Yeah, that little voice of doubt, that moment of self-correction, it sounds completely human, right? Well, it's not.
That thought actually came from an advanced AI while it was working through a math problem. You see, these new models can think out loud, generating thousands and thousands of lines of their reasoning. The big problem is, it's kind of like listening to a long monologue in a language we don't really understand. How do we even begin to decode the structure of it all? And that is the central puzzle for us today. Is an AI's thinking just some chaotic storm of data and calculations? Or is there a hidden, maybe even predictable structure to it all? To figure that out, we're going to need a map.
So, how on earth do you decode an AI's inner monologue? Well, the answer, and this is pretty wild, doesn't actually come from computer science. It comes from a place you might not expect at all.
The researchers figured, okay, we need a blueprint for how a rational mind solves a problem. And they had a brilliant idea. Where's the best place to find one? A math class. For decades, cognitive scientists and educators have been studying exactly how students think, how they struggle, and how they get those aha moments. So they basically dusted off this powerful tool from the cognitive science archives called Schoenfeld's episode theory. It was developed way back in 1985, and it came from analyzing tapes of actual students thinking out loud as they solved problems. The big idea was simple. If this framework can map a human student's mind, maybe, just maybe, it can map an AI's.
So what are these building blocks of thought? Well, Schoenfeld's theory argues that anytime you or I solve a hard problem, our brains tend to move through a pretty predictable set of 7 steps, or what he called cognitive episodes.
Okay, so the first 4 are probably exactly what you'd expect. You read the problem, you analyze the details, you come up with a plan, and then you implement it. Standard stuff. But the real magic happens in the other 3. Explore is for when you get stuck and just start trying different things. Verify is that absolutely crucial, let me double-check my work moment. And monitor, well, that's the wait, hold on step we started this whole thing with.
And this is where it all just clicks. When the researchers started mapping the AI's own thoughts to this very human framework, the fit was pretty much perfect. I mean, look at this. The question asks us to find, bam, that's the read phase. Next, we will differentiate, clear as day, that's a plan. And there it is, right there under monitor. But wait, hold on. That's not just a machine calculating, that's a machine reflecting on its own process.
So the theory fits on paper, but would it actually hold up under pressure? To find out, the researchers decided it was time to officially enroll an AI in school and give it the ultimate math test.
So here was the setup. They gave an AI called DeepSeek R1 more than 1,300 SAT math problems to solve. Then they did the hard work. They sat down and manually analyzed its entire thought process, all 3,087 sentences of it, labeling every single one with one of those 7 cognitive categories. It was a huge, huge undertaking.
Now, you can probably see the problem here. Manually grading an AI's homework is incredibly slow. It's just not scalable. So the researchers asked a really fascinating question. Could we get one AI to grade another AI?
And the answer was, sort of. On its own, a powerful model like GPT-4 was accurate less than 60% of the time. But look what happens when they gave it the same guidebook the humans were using. Its accuracy shot up. The lesson here is pretty clear. Even an AI needs a good teacher and a clear rubric to really understand how another AI thinks.
Okay, so the experiment was finished, and the AI's test was graded. It was finally time to look at the report card. Did the AI think like a star student, or was its reasoning something completely alien to us? The #1 finding was just stunning. The AI's mind wasn't some chaotic black box at all. Its reasoning process fit that human framework almost perfectly, moving through the same kinds of logical, structured stages as any human student would.
Now this chart looks a little complex, but it's really just a roadmap of the AI's thinking. It shows the most likely next step it's going to take. For example, after the AI makes a plan, there's a 40% chance its very next thought is to implement that plan. And once it starts implementing, look at that, it's super likely to keep implementing. This isn't random, it's a logical, predictable sequence of thought.
So the ultimate takeaway here is a fundamental shift in how we see AI. For years, we've treated advanced AI reasoning as this mysterious black box. We know what goes in, we know what comes out, but the middle is a total mystery. This research basically gives us the key to turn that black box into a transparent glass box. We can actually see the patterns, understand the process, and for the first time, really analyze the structure of an AI's thoughts.
This kind of breakthrough gives us a whole new way to not just analyze, but to actually improve AI reasoning. Which leaves us with a final, fascinating question to think about. Now that we can finally read an AI's mind, what's the very first thing we should teach it?